This is the given problem. I will read the problem, then we will solve it. A short column 300 mm by 400 mm is provided with 8 bars of 16 mm diameter, and it is effectively held in position at both ends but not restrained against the rotation for a length of 3 meter. Find the safe load if the factor of safety is 2 and use M20 and Fe415. Okay, so we will see now how to solve this problem. Okay, so to solve this problem now, here one condition is given. Okay, this condition effectively held in position. This condition, we can use this condition to find out the effective length of the column, as only the length of column is given to. So length of column is 3 meter. From this condition we can find out the effective length of the column. Okay, so first of all we will write down the given data. So the size of column is given to you. So size, it is given as size of column. So size of column is 300 by 400. From this size you can find out the gross area. Okay, second, they have given you length of the column. L is given to you. So length of the column is 3 meter, which is nothing but it is 3000 mm. This is the length of the column. Then factor of safety is given to us. Factor of safety is 2. Okay. After that FCK. FCK is 20 Newton per mm square, and Fy is 415 Newton per mm square. Okay. Apart from this, we can calculate the gross area now. Gross area Ag is equal to, it is 300 into 400, which is equal to 4 into 3, 12, 1, 2, 3 and 4. Please check the calculation on calculator if any zero is missing. So this is our gross area of the column. Okay. Now area of steel also, we know that what is the area of steel? It is 8 bars of 16 mm diameter. 8 bars of 16 mm diameter. Solve this and let me know the value of area of steel now. What is the area of steel? So it is 1608.5. Okay. So it is 1608.5 mm. Okay. Now the further part is we can calculate the area of concrete also. We know gross area, we know area of steel. So from this we will calculate the area of concrete. So the area of concrete AC, it is nothing but AC is equal to, it is AG minus ASC, area of steel, which is equal to 1, 2, 1, 2, 3, 4 zeros minus 1608.5. Do this calculation and give me the answer. So the answer is 11839. Okay, 118,391.5. So 118,391.5 mm square. This is the area of concrete. Okay. Now we are going to find out the effective length of the column first. What is the effective length of the column? Okay. So here effective length. Effective length of column. Now to calculate the effective length of the column, we will use the clause in the IS code, which is given on page number 94. So go to the IS code and open page number 94, table number 28. I think so. So here we will go to the IS code now first. So IS code, for IS code, see here, table number 28. Okay. So this is table number 28, effective length of compression member. Okay, effective length of compression member. So here from this table now we will get the value of L effective, and please keep in mind we are going to look the recommended values of effective length. Always we are going to refer the column number 4, we are not interested in theoretical value. Recommended values means what? In theoretical values, some corrections are added, okay, depending upon the moment and the what we can say more degrees of freedom. Okay, so single degree of freedom is here. So depending upon that, some correction is added. So you will learn that in higher education in MTech also, and by adding those corrections, we will get these recommended values. So now, what we are going to do, first thing is that we will see where our condition is there. So our condition is effectively held in position at both ends, but not restrained against the rotation. So effectively held in position at both ends. So here if I read effectively held in position and restrained against the rotation in both ends. But in our condition, not restrained is given. Okay, so this first condition is not there. Second, effectively held in position at both ends. Okay, true. Restrained against the rotation at one end. Okay, so restrained against rotation at one end. So one end is restrained. This condition is also not there. If we go for a third condition, effectively held in position at both ends, but not restrained against the rotation. So this condition is given to us in the problem. Okay, if you see, this condition is given to us, and we are going to refer this condition. Okay, so effectively held in position at both ends, but not restrained against the rotation. So for that, what is the value they have given? So for this now, the value given is this 1L. So the value of L effective is 1L from table number 28, page number 94. Okay, so this value we are going to take for our further calculation. So now I will move back here. We can say now from table number 28 of IS 456 2000, page number 94, we get what do we get? We get that L effective is equal to 1.00 into L, which is equal to 1 into 3, which is equal to 3 meter. This is nothing but 3000 mm as it is. We got the value of L effective. Okay. Now the rest of the steps are same as per the previous problem. Only this is the new step is there. Okay. When the condition is given in the problem, how to calculate the effective length. This is the only the new part which we have added over here. The rest of the things are same now again. Okay. So the next thing what we generally do. So from this now we will move to the minimum eccentricity. Minimum eccentricity. Okay. So minimum eccentricity we need to calculate. So for this minimum eccentricity, first thing is that first, okay, how do we calculate E minimum is equal to, it is L effective divided by 500 plus lateral dimension, it is lateral dimension, that is you can take here D or B, divided by 30, lateral dimension divided by 30. Now just put the values. Now here your column is a rectangular column, which dimension are 300 by 400. Here if we see our column is now rectangular column with 300 mm by 400 mm. So this is your B, this is D. So we need to take both the values one by one, and we are going to calculate the minimum eccentricity. So first E minimum is equal to L effective. L effective is 3000. Just now we have calculated the L effective, divided by 500 okay, divided by 500 plus, first we will put the value of b over here. B is 300 divided by 30. So you solve this, you will get one value. Let me know the answer. Second, E minimum is equal to, is again 3000. So what is the answer? 16. Okay, so this is 16 mm. Second thing is 3000 divided by again 500 plus 400 by 30. So again do the calculation, let me know the value. 19.33. So the answer is 19.33 mm. Okay, so this is the first part from first. Okay, now second thing is we will always take E minimum as 20 mm. 20 mm. So now adopt greater value from these two. Okay, adopt greater value for E minimum. So I will write here adopt greater value of E minimum, which is equal to, what is the greater value? It is 20 mm. So our E minimum is 20 mm. Okay. After this, calculate the actual eccentricity E. Okay. So eccentricity E is equal to, how do we calculate the eccentricity? It is 0.05 into D. Okay. So it is 0.05 into, it is 400. So what is the answer? 5 fours are 20. 20. So now here if you see, your E minimum is less than or equal to E. Okay. So your E minimum is less than or equal to E. And whenever this condition arises, when your E minimum is less than or E minimum is equal to E, this condition is there. Which formula we are going to use? We are going to use the formula Pu is equal to zero point 0.4 FCK AC plus 0.67 Fy AX. This formula we are going to use to calculate the load. So Pu is equal to zero point 0.4 is the constant, FCK is 20 into, what was the value of AC? 118. Further, what was the value? It is 118391.5. So 118391.5 plus 0.67 into 415 into 1608.5. These are the values. So solve this problem and let me know the answer. Pu is equal to 161.38. Okay. So it is 1161.38 kilonewton. Okay. So this is in kilonewton. So into 10 raised to 3 might be there, or some digits may be there, point. So it is 1161.38 kilonewton. This is the value of Pu. Okay. But what they have asked in the problem, they have asked us for the only the load. They have not asked for that. They have asked for the safe load. Okay. Further, safe load is equal to, so divide this load by factor of 50. 1161.38 1161.38 divided by, so divided by, it is, so let me know the answer. 580.68 kilonewton. So it is 580.68 kilonewton. So write down this and let me know when you finish. So we will move to the next problem. So answer is 1394.37 kilonewton. Please check the answer for the load. Which answer is correct? So 697.2. So this answer is correct. 1394.37. So divided by 2. So if you divide this by 2, then what answer you will get? That answer is also already you have given 697.2. Okay, this is 697. We will move to the next problem now. So in this way, here if you see, we have calculated the final answer. The problem is easy, very easy problem is there. And this problem is asked for 10 marks in the examination, 8 to 10 marks. Okay, so the numericals are very easy. Just you need to follow the steps. Okay. So now the next problem. So the next problem is, this is the given problem. So I will read the problem. A short column 400 mm by 500 mm is provided with 6 bars of 20 mm diameter. The length of the column is 2.5 meter, which is effectively held in position and restrained against rotation at other end. Find the load, use M20 and Fe500. Okay, so we need to find the load and use M20 and Fe500. So same steps are there. There is no change. So now we will start the problem. So size of the column is already given to you, so we can calculate the gross area. Age. So age is equal to is 400 by 500 is equal to 20.23 and 4. Okay. Square. This is the gross area of column. Then reinforcement in column, area of steel, 6 bars are there. Each bar is having diameter 20 mm, pi by 4 into 20 square. So let me know the answer. 1884.95. Okay, so it is 1884.95 mm square. So now from this calculate area of concrete. Area of concrete is gross area minus area of steel. So your gross area is 20.23 and 4 minus 1884.95, which is equal to, let me know the area of concrete, 18,115.04. Okay, 18,115.04. 18,115.04 mm square. This is the area of concrete. Okay, area of steel is known to us, area of concrete is known to us, total area is also known to us. What will happen? So this answer is wrong. Which is the correct answer? 19815. Sorry, 19811. So 9 is remaining. Okay. So it is 19815. Now is it correct? 198,115. Okay. So now this area is correct. So after calculation of this, we will calculate the effective length. Effective length of column, that is L effective. So effective length of column, from where we are going to calculate? From table number 28, page number 94, IS 456 2000. Okay, we get, what do we get now? So we have to move to the IS code. In the IS code, we will see the condition, which condition is given in the problem. So problem, it is said that effectively held in position at both ends, restrained against rotation at one end. Yeah, effectively held in position at both ends and strained against rotation at both ends. So this is at both ends. So this is not the case. You see this, effectively held in position at both ends and restrained against rotation at one end. So this is the condition which is given in the problem. So which is equal to 0.8 L. You see here it is equal to 0.8 L. So we are going to use this now. So 0.8 L. We will just put the value. So L effective is equal to 0.80 L, which is equal to 0.8 into, what is the value of L is given to you? 2.5, 2 meter I think. Correct? 2000 mm. Let me know if the answer is wrong. 25 is 200. So I think it is 2 meter. Okay, 2000 mm, correct. So now we have calculated the L effective also. Now calculate the minimum eccentricity. So minimum eccentricity. So now minimum eccentricity, first thing. Now the column is of size 400 by 500. So first, in that first, E minimum is equal to, now I will not write the formula, we will directly write the values. Okay, now instead of directly writing, I will write the formula. L effective by 500 plus D by 30. So E minimum is equal to, L effective is 2000 divided by 500 plus, consider D as 500 first, by 30, which is equal to 20.67, is 20.67 mm. After this, E minimum is equal to, again, is L effective by 500 plus B by 30. E minimum is equal to, L effective is 2000 divided by 500 plus 400 by 30. So the answer is 17.33 mm. E minimum, in no case it should be 20 mm. So adopt greater value of E minimum, which is equal to, what was the greater value of E minimum? 20.67. Now this is the E minimum. Okay. Now calculate actual eccentricity E. Okay. Now calculate actual eccentricity E. So eccentricity E is equal to 0.05 into D. So it is 0.05 into 500, which is equal to, what is the answer? 5 5s are 25. Okay. So now, who is greater, who is less? E minimum and E. Who is greater? So E is greater than E minimum. Okay. This condition is satisfied here. And if this is the case, your E minimum is less than or equal to E, then what formula we are going to use? So we are going to use the formula for PU. Therefore, PU is equal to, if this is the condition in between E minimum and E, then PU is equal to zero point 0.4 FCK AC plus 0.67 FY ASC. So PU is equal to, it is 0.4 into 20 into AC. The value of AC was 19811.5 something plus 0.67 into 500 into ASC. What was the value of ASC? Okay. Now let me know the answer. PU 2216.38. 2216.38 kilonewton.